This is the sixth lecture on this series of lectures on matrix algebra for this course. And now we speak about block matrices. This is a very short lecture. This lecture we need in order to understand better what we know as Frisch, Vogt, Lowell theorem. And this one is done to understand what happens when we have a regression of this kind, plus epsilon, where we divide, the explanatory variables in two matrices, x1, x2, that can be of different dimensions. And we want to see what happened with this theorem using this concept of block matrices. What is a block matrix? Definition. Block matrix. Okay, suppose for example to have a matrix A, m by n. Then you can always decompose in blocks this matrix in such a way. We can, for example, take A1, A12, A21, and A22 with this one that is n1 by n1. This one is n1 by n2. This is of dimension n2 by n1. And this one is an n2 by n2 with the condition n1 plus n2 is equal to n. Okay. What can we do with these block matrices? We can sum and we can define a product, a scalar product. And for example, if we have A, that is A11, A12, A21, A22, and B, that is B11, B12, B21 and B22 with this one this one is n1 by n1 and this one n1 by n1 n2 by n2 n2 by n2 and then this one is n1 by n2, this one is n1 by n2 and this one is n2 by n1, n2 by n1. Then we can define a sum. We can define a sum of A plus B as the sum of the small matrices that we have created before. Then is like A11 plus B11. And when we have A12 plus B12, A21 plus B21, and then we have A22 plus B22. Okay, the dimension of these small matrices have the same dimension of the matrices that we're summing up. Then, for example, this one is a n1 plus n1 matrix. This is a n1 by an n2 matrix. This one is n2 by n1 matrix, and this one is an n2 by an n2 matrix. Then we can define a product. And how it works, the product. If we do A multiplied by B, then at the end we end up with a big matrix that is A11 B11 plus A12 multiplied by B21. What we have used here, it's the same principle of the product row by column. This is row by call product. Okay, this is the first term. The second term is A11 B12 plus A12 B22. The third element A21 B11 plus A22 B21. And then we get A21 B12 plus A22 B22. And here we define the product. There are some results also for example, the determinant and the inverse of this kind of matrices that can be useful also, for example, in the Frisch for the Frisch theorem, but in this case we don't. I think that they are not so useful for for the aim of the course, and then we get rid of them in this lecture. And with this one, with these results, then we end up this lecture, and we will see in the next lecture.